All right, section 3.3, example 5. Step 1, let's factor. Ooh, how do we factor this ugly thing? Well, that could be fun. Let's start by factoring the denominator. So we'll have x times x, and then 2 times 1. And if we add those, we have 2, positive 2 times positive 1 is positive 2, and positive 2x plus positive 1x is 3x. So if there's something that's going to reduce out of this, then the numerator would have to have a 0 of -2 or -1. Let's go ahead and just use some synthetic division and see if we can use that possibility to factor the numerator. So this is just a little side note. I'm going to go with a little bit narrower pencil here. That undid my narrowness when I changed the color. There we go. So I'm going to go -2. So 2, 5, 4, 1, 2, -4, 1, -2, 2, -4. Nope, that didn't work. So let's try -1. So 2, 5, 4, 1, 2, -2, 3, -3, 1, -1. Waha, we found it. Okay, so far in our numerator, because we did this and it worked, we know we have an x plus 1. That's going to give this graph a whole. And then left over is what we've got here, which is 2x squared plus 3x plus 1. So now we can see if that factors. So let's try again. So far, for our function g of x, we have the factors x plus 1. We're going to see if this other part factors or not. And then that's going to be over our factors x plus 2 and x plus 1. Okay, so 2x squared plus 3x plus 1 would have to be a 2x times an x to get our 2x squared at the beginning. And then we need 1 times 1 to get our plus 1 at the end. And then we have 2x times 1 and 1x times x, or 1 times x. So we add those together and we get 3x in the middle, and then 1 times 1 is 1. So those factors do work. Okay, while I was waiting for those announcements to finish and I had my video paused, I've kind of clarified some things here. So we factored the denominator, we used the zeros and synthetic division to discover if any of those zeros were also zeros of the numerator, and that helped us to factor it, and then we took that quadratic and factored it again. So here is our factored form for our rational function. Alright, next step is we're going to go ahead and find domain. So our domain from our denominator here is that x cannot equal -2 or -1, right? Then, knowing that, we can cancel one of these, and that leaves us with this reduced function. Let's go ahead and find our x and y intercepts. So we're going to have x-intercept by taking our numerator and setting it equal to 0, x plus 1 equals 0, 2x plus 1 equals 0. So x will equal -1, and x will equal -1/2 when we move over this one and divide by 2. Then we have our y-intercept. So notice this was more than 1. Y-intercept, I totally spelled that wrong, but okay. We're going to do that by plugging in 0 into our reduced one is fine. So 0 plus 1 times 2 times 0 plus 1 divided by 0 plus 2 gives us 1 times 1 divided by 2, or 1/2. So y-intercept at 0, 1/2, x-intercepts at -1/2, 0, and -1, 0. Okay, let's graph those. -1, 0, -1/2, 0, 0, 1/2. All right, next step we are going to do our asymptotes. So let's do our vertical asymptote based on the domain. So domain is x cannot equal -2 or -1, but the -1 factor canceled out. So that means our only vertical asymptote is at x equals -2, because there's a hole at -1. Alright, next we have horizontal or slant. So we're going to look at the degree of the numerator is 3, which is greater than the degree of the denominator, which is 2. I'm looking at my original for that, but it works for the reduced as well, which would be degree 2 over degree 1. So that means it's going to be a slant asymptote, not a horizontal asymptote. So now, to find that slant asymptote, we need to do polynomial long division. This looks exciting. Let's go x squared plus 3x plus 2 divided into 2x cubed plus 5x squared plus 4x plus 1. Alright, so we're doing polynomial long division. What do we multiply x squared by to get 2x cubed? Well, the answer to that is 2x. I tried to change the color, it didn't work. Okay, so 2x times x squared is 2x cubed, and then 2x times 3x is 6x squared, and then 2x times 2 is 4x. Draw the line, change the sign, so that cancels. We get -x squared here, we get 0 here, and we add 1. Okay. Alright, so let's see if we can multiply again. We can multiply by a -1, because x squared goes into -x squared -1 times. So -1 times x squared is -x squared, -1 times 3x is -3x, and -1 times 2 is -2. Add those. Oh, but we have to change the sign. So change, change, change. So that gives us, I don't know why I'm going through all the bother of changing the signs, because the remainder doesn't matter. We don't care. We don't care about the remainder. Okay, all we care about is this part right here, the 2x minus 1, because that is our slant asymptote at y equals 2x minus 1. Alright, let's throw our asymptotes in there. So we have a vertical asymptote at x equals -2, and we have a slant asymptote at 2x minus 1. So that's a y-intercept, let me mark some points here, a y-intercept of -1, and then an asymptote of 2 up 2 over 1, rise over run. So in there somewhere, right? Let's sketch that in. Alright, now we already have quite a few points right here telling us that our graph is most likely blah 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 in there. I didn't graph that very well, but you get the idea. And then likely we're going to have another piece of it in here, especially since I can see my little cheat from technology here, that yeah, that's where the other piece is. To figure that out though, you would plug in points in that general vicinity to figure that out. So x, y, plug in some points like -3, maybe -4, you know, anything that's going to be in this vicinity left of -2, maybe -2.5 to get some of the points going this way. I don't know if we need that many, but at least one of those at -3 would be helpful. So to get that, we'll just plug that into our original. No, we won't do our original. We're going to plug it into our reduced one. So just let's do that one point real fast. So -3 plus 1 is -2, and -3 times 2 is -6 plus 1 is -5, and then -3 plus 2 is -1, so that's divided by -1, so that's going to be 10 divided by -1, which is -10. So at -3, we have a point at -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be more like there. I'm going to erase this little part right here. Expand these so that this one goes choo-pa-choo-pa-choo, and this one goes doo-pa-doo-pa-doo. Sound effects make everything better. And then we've got our graph in here. I still did a horrible job of sketching that, but you get the idea, I hope. Thank you.